It just means get the letter by itself and everything else to the other side. So we have to do opposite operations. So that's another thing. Oops. Opposite operations. And when we work backwards, when you have multiple steps, we actually start at the bottom of BEDMAS and we work backwards up the top. It's like we're undoing the zipper. If we started at the top and we unzippered it, now we got to zipper it back up. So we start with the add and subtract. So when we do BEDMAS, we usually go this way. When you're trying to isolate the variable, you actually work backwards. So the first thing you get rid of is the add and subtract. The second thing would be the divide and multiply. All right, so here we go. Let's do some examples. And then we've got some word problems to do, and then you can have the rest of the period to work on your assignment. Okay, so first thing I want to do is I want to get rid, we've got to multiply by 3 and we've got to subtract 8. So we need to do the subtraction first and then get rid of the 3 second. So we work backwards through BEDMAS. So we start at that add subtract. So if it's a subtract 8, we're going to add 8. If we add 8 to the left-hand side, we have to add 8 to the right-hand side. So that's going to leave me with 3a over here, and 4 plus 8 is 12. So now I need to get rid of that multiply by 3. So the opposite to multiplying is dividing. So I'm going to divide this side by 3. If I divide the left side by 3, I have to divide the right side by 3. So 3 divided by 3 leaves me with 1a. Did I have to write the 1? No. Are you wrong if you write the 1? Also no. You can do it either way. And then 12 divided by 3 is 4. All right. There we go. Okay. So if I look at this next one here, I have an add to, so that'll be the first thing I deal with. And then I have divide by 6, so that'll be the second thing I deal with. So I always want to deal with that add or subtract first. So if it's an add 2, I'm going to subtract 2 from both sides. And if you want to rewrite it out so it looks a little nicer, you can go 26 minus 2 equals z over 6 plus 2 minus 2. If you like writing it out that way, if that makes more sense to you, writing it as a different line, I just tuck it underneath. That's the way I do it. So I have 24 equals z divided by 6, because plus 2 minus 2 gives me 0. If this is written as fraction form, we know that little line is divide. So we are going to now, opposite to divide is multiply. So I'm going to multiply this side by 6. If I multiply the right side by 6, I have to multiply the left side by 6. And I don't know what that is. I'm going to get my handy dandy calculator out. Well, 6 times 24. So that's going to be 144 equals z. Because this 6 divided by 6 gives me the 1, but this time I didn't write it. Now I'm kind of into the other areas thing. I'm just going to, just so we don't get mixed up, I'll even change colors just so we don't get mixed up. Okay, you try this next one because it's almost like the one we just did. You do that one. I'm going to pause the screen so you can't see what I did, and then we'll double check our math together. You borrowing a calculator?
I don't have that.
You don't have that? Right there on the first shelf. Are we close? Can I show you? Are we good? Can I show you if you've tried? Did you guys get that math? You added 10 first, right? Because we're going to deal with that subtract 10. So you add 10 to both sides. And then you got to multiply by 5. So if you made any mistakes or you didn't quite get finished, please make sure that you have all the notes copied down. All right, let's move on to the next one. Okay, this is a little bit of a weird one, not terribly a big deal. Is 5 positive or negative? Is there a sign in front of it? So we know that it's positive, right? If there's no sign stated, we know that it's positive. So if it's positive, the opposite to that is going to be subtracting, because a positive 5 minus 5 is going to give me 0. So if I minus 5 from this side, I have to minus 5 from this side. So I'm left with negative 7t equals 35. And so this one's a little bit difficult because people want to add, but what's the operation between the 7 and the t? What's happening there? Multiplication. So we need to divide, but we're going to divide by a negative 7. So negative 7 divided by negative 7 is still 1. So I'm left with 1t on this side. And 35 divided by a negative 7 is a negative 5. So those ones can be a little bit confusing because the mistake that I see a lot is that people think they have to add 7. But you have to remember that these things are multiplied together. They're multiplied there. So we treat it like a negative 7 coefficient. And you know how to deal with that, so that's not a big deal. Okay, next one. I have a negative 6 plus 12x. So if I want to get rid of a negative 6, the opposite operation is to add 6. And if I add 6 to the right-hand side, I have to add 6 to the left-hand side. So I have 96 equals a positive 12x. You can write the plus sign there if you want to, but you don't have to. And then we're going to take the 12, and we know that they're multiplied, so we're going to divide by 12. Whatever we do to one side, we have to do to the other. So 96 divided by 12 is 8. All right. Okay, this one looks a little funky because it's got decimals in it, but there's nothing wrong with decimals. You can use decimals. You might need a calculator to be helpful here, just because dividing decimals and multiplying decimals is not super fun. So I want to get c by itself. So I'm dividing by 3, and this is a positive just like this one over here. The 14 is a positive as well, so we're going to have to minus 14.2, so those cancel each other out. And we're going to minus 14.2 to the other side. So I'm left with c over 3 here. And I'm going to use my handy dandy calculator, 8.7 subtract 14.2. And I get a negative 5.5. Pretty straightforward. I'm dividing by 3, so I gotta do the opposite. So I'm gonna multiply by 3, multiply by 3. And again, I'm gonna use my calculator to help me out just so I don't make any mistakes. And my answer is negative 16.5. All right, this one's a little bit different. This one here is a little bit different. Normally I want to get the letter by itself, but I have two different m's. I have a 5m and I have a 7m. So I need to bring all my m's to the other side. So I know that the 7 and the m are multiplied. Like I know that that's happening, but I want to bring this whole term, I want to bring it over here so all my m's are on the left-hand side. So all I'm going to do is if this is a positive 7m, I'm going to subtract 7m because I want that to go away on this side. And if I do it to the right-hand side, I have to do it to the left-hand side. So this goes back to combining like terms. 5m subtract 7m, or a positive 5m with a negative 7m. I'm left with, anybody? If I get my algebra files out again, I don't know if I have enough. Did you grab 2 packs? Oh. All right, so I have a positive 5. 1, 2, 3, 4, 5. And I'm going to combine it with 7 negative. Kind of all over the place. Kind of falling off here. I need 3. Okay. What do we got? What's left over? What's left over? Remember that a positive and a negative cancel each other out. So that's 0, that's 0, that's 0. Those two make 0. Those two make 0. What am I left with? Negative 2. So we're left with a negative 2m. And now we're back to regularly scheduled programming. Now we can just divide by that negative 2. And whatever we do the left-hand side, we have to do the right-hand side. So m is equal to a positive 8. You got to remember your rules. You got to remember your rules for integers. 2 negatives divided or multiplied are going to give you a positive. Okay, last one, last basic example, because then we're going to get into word problems. And word problems are probably the toughest. So ignoring word problems means that they might not go away. You just might not be prepared to deal with them yet. So let's get through this last example and we will keep trucking on to the word problems. So I have a subtract 4 or a negative 4 here. So the opposite to that is add 4. Whatever I do to one side, I have to do to the other. So I have 21 equals negative x. What's the coefficient on that? What's the invisible number that we can't see? 1. 1. So that's like saying there's an invisible that x is being multiplied by a negative 1. So it's just like if it was a negative 3, we divide it out by dividing negative 1. So that would become a positive x, and this would become a negative 21. And the more comfortable you feel with integer rules and working with those numbers, the faster you'll get at this. But don't rush it. If you're not comfortable yet, use your calculator, use algebra tiles if that helps. There's all kinds of tools available to you that can make it go a little bit smoother. All right, word problems. Oops. Ooh. Okay, when a variable is in the denominator, you need to multiply it up to the other side. Then isolate the variable just like we did before. A cannot equal 0. This is a restriction. It's not part of the equation. It's what the variable cannot be. When solving it, so this isn't part of the equation. This is kind of like, hey, this is the only thing A can't be. Because if you take 4.2, let me put it in my calculator. Oh, let me clear this off. If I take 4.2 and I divide it by 0, my calculator's gonna give me an error. And if you don't have that kind of calculator that tells you what the problem is, I'm going to do it on this one. So if I take 4.2 and I divide it by 0, it tells me that I've got a math error. And if I take another calculator and I go 4.2 divided by 0, it gives me a 0, but it gives me the letter E telling me that there's something wrong. So in all my calculators, it has told me that there's an error, there's something wrong there. So if you notice my poster on the wall, it's all fun and games until someone divides by 0. You cannot divide by 0. If I said, okay guys, I want you to get into 0 groups. I want you to group yourself 0 times. We can't all stand together because that's one group. And you can't all stand apart because that's 10 groups. So 0 doesn't work when we're talking about grouping. So we're going to deal with this by getting it off the denominator. So this is divide by A, right? So right now we're just going to ignore that restriction for right now. So maybe I'll rewrite the equation. 4.2 divided by A equals 1.68. So there's no add or subtract, so I don't have to worry about that. It's a divide by A, so we're going to times by A and times by A. So those A's are going to be equal to 1. And 1 times 4.2 is just 4.2. And if I want to get A by itself, I have to divide by 1.68. Divide by 1.68. And that's going to give me 2.5. So if you have a variable on the bottom, you have to multiply it up to the top level, just like you would before. You can't deal with it on the bottom. It has to be upstairs. So we can never divide by 0. And when, like we're doing that in grade 12 math, you see on the board, 1 divided by 0, I have a UD beside it. That's undefined. And in a graph, it gives an invisible line, an invisible like wall that you can't cross. So that's what we're doing in grade 12. We're using the same stuff that you guys are learning now. We're using it in our grade 12 class. All right, write an example representing the statement and solve for the unknown value. You guys need to remember to read the entire sentence. We have to create an equation, and then we have to solve. Okay? So you get some marks for creating the equation, and you get some marks for solving. If you only create the equation, then you're only going to get part marks. Okay, 5 more than 3 times the number is 19. Okay, let's pull out some stuff we know right away. What did we do with that on Wednesday? Remember we had to give a letter? So we got to define the letter. So we're going to say what letter are we going to use today? Q, okay. Let Q equal the number. So we're going to define our variable. And I'm going to start here. 3 times the number. What is that going to look like in an algebraic sentence? Just in an equation. What's 3 times the number? What's that going to look like? Isn't that just going to be 3Q? Right? I'm working all over the place here. Is 19. What's the word is mean if we want to put a math symbol by it? Equals. So that's equal to 19. Let me grab a green maybe. Maybe green. All right. 5 more. 5 more. If you have $40 and I give you 5 more, how much do you have? If you have $40 and I give you 5 more, you have 45. What math did you do? You added. So we're going to say we have 5 more. So we've made that into a sentence now. We've made the sentence into an equation. So I've done the first part. I've created the equation, so I get the marks for that. Now I got to move on to the solve part. I want to show you one of my grade 12's tests. Let's see if I can find her test in here. Because I want to show you a strategy that she used when doing a really, really hard question. Of course, Edith. All right. Okay, this is Riley's test. She's in my grade 12 class next period. This is a really hard question. You can see all the tough math that she did. She had to draw me a picture and stuff like that. But so she went through and she circled all the important parts in her word problem. So that's a strategy that works for her. So she was highlighting things that made sense. So it is a strategy that might be helpful for you when you're dealing with those tough word problems, to go through, highlight, circle, those sort of things. I find highlighting works for me. Okay, so now we're to the solve part. This is the easy part. I'm going to subtract 5 from both sides. So I have 3Q equals 14. Divide by 3. Divide by 3. Does 3 go into 14 evenly? It does not. So remember that in the last lesson that we did, we said we would just leave it as an improper fraction. We just leave it right there. Don't even need to grab our calculators, but I did need to know a little bit about 14. Is it divisible by 3? And I could check in my calculator. And if I go 14 divided by 3, oops, you guys can't see that because of the lights. I get a repeating decimal. Right away, I'm going to put my calculator away, and I'm just going to leave it as that improper fraction. Okay, now we have more words in this last example. Stephanie has a job in sales. She earns a monthly salary of $2,500. Okay. So $2,500. And then we have this word here, plus. What do you think that means mathematically speaking? Addition. 8% of her sales, 8%. What does 8% look like as a fraction? We did that the other day. What's 8% as a fraction? What's the perfect number on a test? 100. So what is 8% going to be as a fraction? 8's going to be my top number. What's my bottom number going to be? 100, the perfect score. So I'm going to write some things. I'm going to scribble all over the question just to help me get some things down. Last month, she earned a total of $27.80. Write an equation to represent the situation, then solve to find Stephanie's sales for that month. Okay, so if Stephanie sells absolutely nothing, she earns still $2,500. That's what she, plus 8% of her sales. So what variable are we going to use to represent how much she makes in sales? What letter do you guys want to use? Anybody? N? S? M? Okay. Let M equal the amount in sales. But we're not giving her the full amount in sales. We're only giving her 8%. So if I take 8 and I divide it by 100, I'm going to get 0.08. So we're going to take 8% of her sales. So 8%, and what did I say last time? I said anytime we're dealing with percent, it's a multiply. So we're going to take 0.08 and we're multiplying it by M because that's the amount of her sales. And she earned $2,780 last month. All right, here we go. So I created the equation. Done. And now I have to solve for finding out how much Stephanie made in sales that month. So first thing I'm going to do is I'm going to remove the constant by subtracting it from both sides. So I have 0.08 M equals $280. I don't know where I was getting the 7 from. $280 left. And now I have to divide by a decimal because these two things are multiplied together. So I'm going to divide by 0.08. $280 divided by 0.08. So she made $3,500 in sales. And I want to put my units of measure. It's money, so I want to put the dollar sign. If you've been taught in French and you put the dollar sign at the end, that is okay too. And I heard that in French, they only use $1 sign line. Weird. I've always done 2. But I'm okay if you just do 1. If you want to do the Francophone way, I'm okay with that as well. So that question was probably one of the more difficult ones. But you're probably going to see it on a problem set, and you're probably going to see it on your test. So I put a little asterisk by this, that maybe this is something that needs to go on my cheat sheet when I make it. Okay, that's it. That's all. That's it for today. And it's Friday. We made it to Friday. This was our first 5-day week in a long time. We made